Alright, I believe I told you this before, but today we're going to go over Chapter 16, which is on object-oriented programming. Tomorrow we'll go over Chapter 17, which is on functions, modules, and closures. And Friday we will go over Chapter 18, or whatever it is. I think it's 18. And that is on AJAX and APIs and a lot of other goodies. Okay? Now, I sent you this article this morning. I'm sorry that this is, let's see if I did this. Let's see if I put something underneath there.
It looks like the land or something up there, the land because
It's close enough. Yeah, right. It's like me. It's better. How about that? But I sent you this article this morning, and there's, you know as well as I do, there's millions of articles out there on this stuff. I wanted to find something that was small, that would go back and give us a review of what object-oriented programming is. Now, I don't want to sit and read to you. All right. But basically, object-oriented programming works with objects that communicate with one another. All right, and objects contain properties and methods. And I've used this example before. If we had a person object, your properties would be things like your height, your weight, your eye color, your hair color, your gender, etc. And your methods, which is, and all methods are, they're functions within objects, but your methods would be eat, drink, sleep, etc. All right? And objects are instantiated or created from classes. So the act of creating an object from a class is known as instantiation. All right? That's pretty much what they say in here. Now, believe it or not, and I may have told you this already, I don't remember, but when I decided I was going to at least try to move here, they had a job open at St. Charles Community College. And this one wasn't open at the time. So I applied for it, and they did an interview with me, and it was an online, or over the phone interview. And this was the interview, basically. They wanted me to explain the 4 components of object-oriented programming. In other words, they wanted me to tell them what encapsulation was, what abstraction was, what inheritance was, and what polymorphism was. And they didn't give me any idea before the interview of what we were going to talk about. And evidently, my answers to them weren't acceptable or weren't as acceptable as other candidates they had. Now, I'm not going to go and bash that school. I've never set foot inside of it. But I have had several students who have. Maybe it's better on here. Just put it that way. All right. So, as it says, these are the 4 basic concepts. So let's quickly talk about them. The first one, as it says, is encapsulation. And they give the idea here, it's like, for example, imagine that if, I don't even know if they still make those pills, but I remember you used to see a thing on commercials on TV for this cold medication called Contact. And basically they showed, it was like, they showed that when you swallow it, like the pill opens up and all these things that are inside come down, etc. But basically all the medicine in that case was hidden kind of inside of the outside of the pill itself. Well, in the same way, when you work with encapsulation here, you've got 2 major things. You've got an interface and you've got an implementation. Your interface is what you show the world. Your implementation is what takes place out, under the hood. And the idea is what you would like to do as a developer is to hide as much of the detail as possible. You don't want people to be able to understand, what you're doing underneath the hood. Because if they did, they'd make, I can make that better, and then they'd screw it up. All right? And I've given this example before. I'm not going to bring it up. But for example, if I brought up a calculator and put in a number and hit the square root key, it would give me the square root of the number. I don't know physically how that's wired into this, to make that happen. I don't care. All right, all I care is the interface that I have. If I go and ask basically via the interface what I want, then I get back the answer I want. But the good news is if somehow someone decided to come up with a square root, let's say they came up with a new way of figuring out square roots that got the answer a lot faster. They could, essentially, they could change that in a calculator, all right, and as long as my interface didn't change, I would be none the wiser, except hopefully I'd be getting the answer back faster. All right, and going along with encapsulation is abstraction. It says it's like an extension of encapsulation. It hides certain properties and methods from the outside to make things simpler. Well, it's even more than that. Now, JavaScript technically doesn't really look at those ideas that you'll have next year or next spring in Java, where things are either public or they're private or they're protected. All right. But the reason that you typically, in some languages where you have that you make things private, is you want to make sure that there's only certain things that can change whatever it is you're working on, whatever you've made private. I've said this before, you probably have heard it. If you ask me for a one-sentence definition of most object-oriented programming languages, it's using public methods to manipulate private data. And that's normally what you want. So the only way that you can manipulate that data is through the methods that you create. All right, and that's what they're getting to in here. As it says, it helps isolate the impact of changes made to code. So if something goes wrong, it won't affect the whole program. The program will be able to run. All right. Inheritance, again, we've talked about good, bad, or indifferent. When we look at inheritance, and we will today in just a bit, it's a lot like the inheritance is in Java. Basically, it uses the same keyword, which is extends. So if you want one class to inherit from another, the class you're inheriting from is the parent class. The class that that is doing the inheriting is the child class. They go by other names, superclass and subclass, and there's even other names, but it's not really that important. As it says, the main object of the superclass and all the objects that following it are subclasses. But the idea is, by default, in this language especially, the subclasses of the child classes get everything the parent has. Now, before we even quickly just discuss polymorphism, let me just say that every language handles this a little bit differently. And JavaScript is no exception. In fact, when JavaScript was first created, it was not created as a language that you'd use for really big applications. It was not created for that. It was created to provide simple interactivity to the browser. And over time, things have changed. And people have added stuff to it that it really and truly wasn't designed to do. And over time, JavaScript has morphed. Why am I telling you that? Because the first thing we're going to look at, actually it's one of the things that we'll look at in the chapter, but it's the first thing we'll look at in the examples we're going to go over in a bit, is the way you used to do object-oriented programming in JavaScript was you'd use basically what are referred to as prototypes. And it's unlike any other language that I know. All right? But really with ES5 and ES6, so in the last 5 or 6 years, they have changed it. So really, it looks almost exactly the way that you're going to do things next semester in Java. All right? Finally, polymorphism, as it says there, means many forms. All right? And it's the idea that if I've got a parent class that's way up here, and you've heard me say this kind of thing before, and I call it animal, all right, and I say all animals have, I put a big method up there, and all animals I say can speak, all right, and I might just make a default thing in there that says speak, literally the word speak. But then if I've got a dog class and a cat class and a bird class, they all speak differently. But since they're all inheriting from animal, I can override the speak that I have inside of animal so that a dog barks, a cat purrs, and a bird twerps, or whatever the heck a bird does. Plus, if I've got something like a fish that, to my knowledge, doesn't really make a lot of noise, they can still use the default speak. All right, so in other words, I can have many different kinds of objects that can respond differently to the same method. That's polymorphism. All right, and then they start to give at least some examples of each in here. And to be honest with you, I didn't think they were that bad. I didn't think they were that great. So you can take a look at them, but I just wanted to just throw at you those 4 ideas. Now, one thing, the last one that we just talked about, polymorphism, JavaScript isn't the language for things to do polymorphically, just so you know. It handles the other stuff pretty well, but not that one as much. All right, so with that said, I'm going to jump into the chapter. So this is one of the longest, if not the longest chapter in the book. Now, the first thing they're going to show you there, I'm not going to read these to you, but one of the first things they're going to show you in there is there are different ways that you can create objects. And they're going to show you all of them. All right? Again, I'll give you my recommendations, but they're going to show you all of them. Then they jump in kind of to doing it the newer way, in that they're going to talk about classes. All right. Then they back up and they go into prototypes. All right. And then they kind of try to put a lot of more advanced topics in here, like iterators, generator functions, cascade. We're going to spend not real much time on this. I mean, that's fairly advanced stuff. Now, I didn't, I think I've got it over here still. I actually found what I consider to be at least a decent free resource. I found 2 free Udemy classes that this guy has out there. English is probably not his first language, but he speaks it very well. And in his advanced class, it's all on object-oriented JavaScript. I will send you the links during the break today. They're free. You know, take a look at it. If you think, well, I can learn something from there, look at it. If you plan on getting a career in web development as opposed to app development, as opposed to maybe working at a place like MasterCard where they use Java, etc. Right? But if you are going to do something that if you want to be a web developer, you're going to have to understand JavaScript. And if you're going to work for a company that already has stuff created, you can almost be assured that somebody will have used classes somewhere along the line. Okay? And in between here, they've got the miles per gallon program that they do with object-oriented, the trips program, which basically says, where did you start, where did you end, where did you go, and it's more or less, it's a build-on of this miles per gallon program, and this task list, which is a simple to-do list, which we've been looking at previous. All right. So I'm going to concentrate more on the pages on the right. So if you look at this example, the key thing to realize, look at the top example on page 505, that when you are creating a new object, you must surround it with curly braces in JavaScript. That means object. You may or may not have noticed this, but yesterday, I'm not going to go back to that, but when we looked at the arrays, and when I took that array and I gave you that array of numbers and I initialized it, in all the other languages we've learned, you put them in curly braces. Not here. All right, because if you were to put those in the curly braces, it thinks you're working with an object and it gets confused. So what this does, it creates an empty object, which means that this particular object has no properties. This particular object has no methods. It's empty. All right, why would you want to do that? Well, if you know you're going to work with something later, but you at least want to have it out there, you could do something like that. Then in the second example here, now they have created another object, well, really an object with the same name. Now they're kind of filling it in. So you'll notice they've got a property in there, and they've got a method in there. All right, you're going to see all this stuff as we go on. Then notice that you use dot notation. So if I want to reference the tax rate, it's invoice.tax rate. And if I want to basically invoke the get total, it's invoice.getTotal. All right? You can have an object inside of an object. right? And people get confused with stuff like that. This isn't a terrible example, but imagine that you had an object that you called street address. And then inside of it, you had sub-objects or another object that basically where you put in, so let's say it was just called address. Then inside you might put in street address, city, state, and zip. So you could have one object inside of another. In addition to that, you're going to see this a little bit later on, there is something that's called composition, where you can have one object can be composed of other objects. Case in point, I probably have even given you this example in earlier classes. If I create a clock object, my clock object might have properties in it like hours, minutes, and seconds. And I might have maybe a couple methods in there, one that were set hours, set minutes, get minutes. Well, if I created another class called alarm clock, an alarm clock is a clock. So I could take and basically as part of the alarm clock, I could put a clock object in there, and then I could add to it whatever I had to add to it. Set alarm, turn off alarm, etc. All right. And there's a lot of really good stuff in here. I don't want to sit and read to you. Okay? But I'd say if nothing else, at least take a look at all the stuff on the right. All right. Again, this is a long chapter. And in many ways, it's a long, laborious chapter. All right? So there's many different ways that you can set this stuff up. All right? And they show you a couple of them here. The idea, all I'm going to tell you is we're going to go through two different ways of doing a lot of the same stuff. I believe it or not, I sent you another file right at the beginning of class. But that said, I'm going to ask that rather than you literally going in there and typing that stuff in, that we type it in together. It's going to take a while, but I think it's going to make a lot more sense to you doing it that way. All right. Now, there's different ways of doing this. So notice it says these would be variables. This is the traditional syntax, but you don't have to do it like that anymore. So notice if it's called name and basically if that's the way you're referring to it and that's its actual value, you don't have to put name, year. This is the shortcut. This is also known as helping to destructure the object. All right. Now, what's kind of cool, especially about the prototype stuff that you do in here, is you can just go in and add on to stuff at any time. All right? So you can go into an object, and after it's been created, even as working, you can go back and you can add stuff into it. We'll look at that in just a little bit. All right? To remove it, as it says, if you want to remove a property, you use delete. All right. Now, it says here two constants that refer to the same object. All right? Typically, when you do something like this, it's not that these two things right here, there, it's not that I copy one to the other. That's not what you're doing. Literally, with objects, typically, if you go to the beginning of where an object is in memory, it's an address. And it's an address of where to go to find the rest of it. All right? But what we're saying in these lines that you see here is both today and now point to that same address in memory. So if you change one, you're changing the other. All right? And that's what they're showing in the example here. Again, I don't know if I'm making it easier or harder to understand, but as I mentioned, read the descriptions at the bottoms of the pages. All right, we've talked a little bit before, and we're going to do very little of this, but there are getters and setters. All right, when you've got a getter, as it shows right there, it just returns something. When you've got a setter, whatever you're working with is going to appear on the left-hand side of an equal sign. So typically, that's one way to tell the difference. That if it's appearing on the right-hand side of an equal sign, it's a getter, If it's appearing on the left-hand side of an equal sign, it's a setter. All right, good, bad, or indifferent. Some books will refer to both of them as getters. Some books will refer to both of them as accessors. All right, I was always taught that getters are accessors and setters are mutators, because mutate means that you are changing the actual value. And again, there are some examples in here that show this stuff. All right. Now, one of the things they get to in here, in fact, they'll show this in just a minute, because I think next on the next page is the miles per gallon program, is they start talking about a JavaScript library. And the key thing actually here, in my opinion, is they show 3 bullets, and it's the last one. They encourage the separation of concerns. So if I know, for example, this isn't a great example of this, but let's suppose that I write my own function to, I know there's sort functions built in, but I figure out a way to sort better than JavaScript can. It'll do it faster, and it'll do a lot of different stuff that the regular sort function doesn't do. What I'd probably want to do would be to put that inside of my own .js file so I can include it in other programs, right? And I can use it on an as-needed basis. And that's one of the things that creating these libraries does. In fact, one of the things, I'll just show you this, and I don't know if I have before or not, but one of the things that we're going to look at, if not next week and the week after that, is we're going to go out to npmjs.org. Let's come. But it's an ugly site. There's not much in it. Other than, from here, you can actually search for about 1 million different packages. All right? And these packages are basically all JS files that people have created and made available so that anybody can use them. All right, so it says it lets you group similar functionality in a single file. That's true. By doing that, it should make your code easier to understand, maintain, and reuse. And then that's that separation of concerns. And when you think about it, you know, I could actually see, let's say that it's May, the end of May, and Gabriel's going in for it. He's applied for a job as a web developer. All right, and he goes in for the interview, and they start throwing questions at him. One of the questions they ask is, Gabriel, explain to me the concept of separation of concerns and why it's important in web development. Well, you already know. You could start with saying, well, one of the things that you do with a website is you separate out your HTML file into a .html file, your CSS file in a .css file, etc. You do all that stuff. Here they're talking about the same kind of thing. All right, they're talking about taking something that's designed to do a specific task, not just a function, but maybe a series of functions or whatever, and throwing them into a library. So they're available on an as-needed basis. All right, and that's, like I said, you could write something and you could send it out and ask that it be put in NPM. I'm not saying they do it, but you could at least, there is a procedure that you can go through to get your own stuff in there. I mean, when you think about it, like I said, with over 1 million things in there, you know, a lot of times what people do is they don't want to reinvent the wheel. They take something that someone else has done or something that exists and they add to it. All right, we're going to talk about Node in a couple weeks, and if you've never heard this story before, it's not a story, but about 12 years ago, the engine that runs Chrome is called V8. All right, there could be a lot of jokes behind there. It could be the V8 juice. It could be V8 engine. It could be anything. I don't care. But the point is, there's a guy named Roland Dahl who said, you know, it would be really cool if I could take this engine, all right, if I could take this V8 engine, add some C++ to it, and allow JavaScript to run on the server instead of just running on the client. That's how this whole thing started. All right. So like I said, with a lot of it, it's people aren't reinventing the wheel. Okay. So again, they have this miles per gallon thing. I'm not going to go through it, other than to say that if you do look in the JavaScript that's here, they do a pretty good job you'll notice the library miles per gallon file, the mpg.js file, etc. Why am I telling you that? Because if I back up a second, you'll notice that when we come down here, both of them have been added. All right. So if you want that capability, now the first thing that's in there is jQuery, and you will need that for certain things. You will not need that for other things. All right. All right. Then they kind of jump forward into more of the way that most of this is done today. So we're going to look at prototypal language, the way that you do it with prototypes, and we're going to look at the way you do it with classes. All right, in that example file that I've given you, we're going to look at both of them. We're going to use both of them. All right. So it says you're probably familiar with classes. We already talked about these. All right. It says JavaScript is a prototypal language that uses prototypes to create objects. Now, that said, just to show you, I've got it in here someplace, so give me a second to find it. So this is the file that we're going to be working with in just a little bit. All right. Okay, so we're going to be working with this, and you're going to notice there's nothing special. When we were working with prototypes, I prefaced everything with proto. All right, and when we went down, and then when we started working with classes, which is a ways down on here, then I prefaced it with class. All right. So you're going to get to see them both. Okay. But one of the things with, and this may or may not make any sense to you, and if it doesn't, it's not a problem. But even if you use this way, which is much slicker and it's much neater than doing it this way, as opposed to doing it the other way that we'll look at first. All right. What happens underneath the hood is the new way calls the old way to do everything. In fact, you may or may not have ever heard of this expression, but working with regular classes in JavaScript is known as syntactic sugar. So in other words, they put, like when we did our alias, when we used that $ for an alias, we were putting syntactic sugar on the document.getElementID, changing it so we only had to use the $. Well, here we're doing it not so much because it results in a lot less typing, but we're doing it because this is the way that most other languages actually create objects and classes. All right. So this is the kind of thing that we're going to do. Now, what's different in here? Well, for instance, next semester, when you are working in Java, okay, if we were to have done this, if we said class invoice like this, first of all, in Java, you must say either public or private. And most of the work we're going to do, it would say public class invoice. Okay? Next, in JavaScript, when you want to write a constructor, you need to use the word constructor. What does that mean? That means that when a line like this here runs, hopefully everybody can, or could see that line that's kind of in blue or gray right there. When that line runs, it goes and it looks for a class name invoice, and it runs all of the code that's underneath the constructor. All right. Now, when you do this in Java, not JavaScript, you don't call it constructor. It actually must be called the same name as your class name. So in Java, this would be called invoice. The difference is the line up above it would say public class invoice, and then the next line would just say public invoice. All right. Okay. And you'll notice that in this case, there's nothing being passed into it. There's nothing in the parentheses. So all we're doing is we're setting subtotal and tax rate in both cases equal to no. We are giving it, that's saying whenever you create a new invoice object, subtotal is null and tax rate is null. That's what this is saying. Plus, you have available to you a method called getTotal. all right, which is going to return basically the total. In other words, it's going to figure out the sales tax, all right, and then it's going to return this subtotal plus the sales tax. Now, you might look at that and go, wait, there is no sales tax. There is none of this. There is no subtotal. Well, this isn't the way you're actually going to do it in real life. What they're showing you is, since you haven't passed anything in, anything else that you might want to use in here, you have to automatically set. All right, that's not a good way of doing things. It is a way you can do things, but it's not a good way of doing things. A better way is what they show down here. So notice it looks similar to what you saw before, except that now we are passing in a subtotal and we are passing in a tax rate. And when you want to refer to the current object, so to speak, you use the word this. That is exactly the same word you use in Java. So there won't be a lot of relearning for you, all right, next semester with a lot of this stuff. And I wouldn't be surprised if Ms. Shelton picked it up fairly quickly, because she's had very similar stuff last spring with Java, or maybe there'll be some relearning. I don't know. All right. So again, when you call it like this, now you must pass it in, as it says there, a subtotal, and you must pass it in a tax rate. Now, I think you'd agree when you look at that constructor up there, it's not doing any checking. So in other words, if we passed in a negative value for subtotal and or a negative value for tax rate, we're not checking that.
Question is, should we?
The question is, it depends. In this language, yes. All right? Now, probably, yes, because remember how versatile this language is. That if I were to pass in there Jeff and Scott, Jeff would become subtotal, Scott would become tax rate. So it would immediately go ahead and set that equal, and those would both be set right here. But then when it called get total to do this, wherever that, those are strings, so it's going to return NaN for all of that. Yes, that's why you should. All right. So you could check for blank, you could check for is NaN, etc. And if that was the case, you could give it a default or just refuse to do it or whatever. All right. So as it says, you can use the JavaScript class to define a constructor. All right. You code the data properties for your class inside of the constructor function, and after that, as it says, you put the accessor properties and the methods outside of there. By default, these classes should start with a capital letter. All right? And in fact, this is about the only time in most languages that you start something with and have just a capital first letter, is when you are creating classes. All right. Then again, I've started to mention this. So when you look right here, what they're saying is, this is real. This is what happens in JavaScript. So string, number, Boolean, date, array, and function are all children of the object class. All right? So the example that we're going to do isn't that different than this. All right? But what I used was I used a person, and I did use an employee, but I don't do it the way he did it. All right, so you're going to see a lot of that. And I did it both using prototypes, and I did it using the standard class way of doing it here. And the reason that you have to learn both is there are millions of lines of code out there that were written before you could do it this way. And they used it using the prototypal method. All right, so you've got to know that. So if that's ever the case, you know how to work with that. So by the end of the class today, you will have had examples of working with both of them. All right. When to use inheritance, I'm going to tell you how I was taught this. And they do show it down here. If you have what's called an is-a or an is-an relationship, that's typically when you use inheritance. For instance, if I create a bank account class, All right, and then I say, oh, it's real generic. All bank accounts have this. They have a number, who owns the account, who can access the account, etc. But then I start breaking it down, and I have a checking account, and I have a savings account, maybe other kinds. Well, a checking account is a bank account. So that would say, yes, you can use, that's a good candidate for inheritance. All right, a savings account, yes, is a bank account type of thing. All right? All right. Now, I already mentioned this to you, but the other one is composition, rather. And more often than not, rather than is a, like you use with inheritance, as it says down there, it's has a. So for instance, if I was creating a car class may contain an engine class, a tires class, a seats class, etc. You get the idea. I may make other classes and then put them all inside of a container type of class. All right, that is an inheritance. A tire isn't a car, all right, but it's a car has a tire. So that's the idea behind it. All right, then they go through this trips example here, and that's it right here. So the destination, how many miles. Basically, it's the same as the miles per gallon, but all you're doing is you're just asking the person where they went and how long it, how many miles it took them to get there. So, and again, with the JavaScript, they're doing a pretty good job because now notice they're breaking it down. So you've got a class called trip and another one called trips. You see this a lot more than you would think you would, where you've got the same name twice, except one is pluralized and the other's not. All right. All right. So this is prototypes, and like I said, the idea is it'll probably take 5 to 10, 15 minutes to finish this chapter, something like that. There's about 20 pages left. All right, and we will finish the chapter. The stuff gets harder as we go on. All right, so we believe it or not, we've hit the easy stuff already talking about classes. And as I mentioned to you too with this talk of syntactic sugar, what is happening underneath the scenes, behind the scenes, is this is the way that JavaScript started out. So what they did was they basically put an alias around it so it looks very similar to the way other languages do it, but underneath the covers, so to speak, or under the hood, this is the kind of stuff that's happening. All right. So you'll notice right there, this looks different. All right. So this is kind of cool. What this is saying in English is JavaScript has a class called date. I'm not asking you that, it does. You can instantiate a date object in your programs. By default, it gives you the hour, minute, second, hundredths of a second, the day, the month, and the year. But if you decided you wanted to go and add your own method to the existing date class called toNumericString, you could add this. All right, and then make it that it would be available. All right. And that's what they're showing here. Now, that's not the only way prototypes are used. You can make your own prototypes. All right. They talk here about legacy code for creating objects. And again, I don't want to spend much time on this because legacy does imply that's the way it used to be done. That doesn't mean, though, that you won't find code out there that's done like this. All right. So again, notice we've got this invoice. Notice what's different. We do not have the word class. We do not have the word constructor. We're creating a constant called invoice where function basically takes the place of constructor, and then other than that, it runs kind of the same way. So again, look at it this way, that with the examples we looked at before, where we had class, invoice, and all the other stuff, behind the scenes, under the hood, whatever you want to call it, this is what's happening. All right? Then when you want to add a method, you've got the name of the class, invoice here, dot prototype dot, and then you put in the name of the new method. So the method is get total. And you notice that you have to say it is a function, and then you put the other stuff in there. So, you know, you can compare and contrast this with what we saw 5 or 10 pages ago for doing the same kind of thing in a class. Now, one of the things that they mention in here, just because, again, you're going to hear this, all right, again, prior class, it was common to do this like this, etc. Again, constructor name start with an uppercase. You already heard that. You can use the static create method of the object type to create a new object that's based on a prototype. Object.create. If you remember when we got into this section, we had that object on top and the other things under inheritance that were children of that. That's the object that they're talking about. It's kind of like the HTML element. It's the thing at the top that everything else are children or grandchildren or whatever. They're all descendants of it. All right. They have something in here, as they mentioned, it says a factory function can use the create method to create and return new objects. They do give an example of a factory function right here. All right. Again, the way that it's done today is much slicker. The way it's done today is you use the word new whenever you want to instantiate an object. And it's done like that in most every programming language, at least the ones I know. All right. Now, this is a little confusing. Like I said, it gets a little harder here. It says, although you typically use the dot operator to refer to properties and methods of an object, you can use brackets. So there's two ways of doing this. So in other words, if you look on the screen here, you can either refer to something, there'll be more that you can refer to something as invoice dot, or you can do it this way. You very rarely see it done this second way. It's not that there's anything wrong with it. Just it is not even that it's so much more typing the other way. It's just that's the way it's done in most other languages is with the dot. That's why I think people use that most of the time. All right, but they show in here. They talk in here about one reason to use a computed value in here is to prevent name collisions. Collisions basically mean that if you imagine that, let's just say I'm writing an application and it gets to be too big for me. So Gabriel comes in and works on it with me. It's still too big. So now Aaron comes in and eventually we're all working on it. And we're each doing our own little piece. And I might have something that's called hello, that's doing something in my program, whatever it is. And Gabriel might have something else in his program that's totally different that's also called hello. We want to make sure when we put our code together that the system can tell the difference between my hello and his hello. And typically the way that you do that is you use what are called namespaces. And we did a little bit of that in the C# class. Now, another way you can do it, and the way that it's done here, is as it says, you typically take what you're working on and what I'm working on, we each get some kind of a variable that's a computed value. It's kind of like an ID. All right? Now, what we're going to start doing, I believe, next week already, is we're going to go back and look again at MySQL. Spend a little bit of time every day probably on MySQL. And after we get done with that, we're going to jump right into MongoDB, which is a NoSQL. The reason I'm telling you that is with MySQL, if you remember, we basically set up a key and we told it to auto increment. 1, 2, 3, 4, etc. When you work with MongoDB, your keys are about 16 or 17 characters long. And there are a series of letters and numbers that automatically get generated for you. All right, that's like a symbol that they're talking about here. All right. As it says, when you call a symbol function in JavaScript, it always returns a unique value. It's kind of like, I always thought of this, that every time I go out to, I don't have it got on the other machine, but every time I go out, in fact, let me show you. Show you this way. So in other words, when I go out, you'll notice that this has got an ID right there. All right? And it's actually was bigger than that, it got cut down. But the point is, every time, not only me, but every time I and other people go in and we create a video, these IDs have to all be unique so that the system can go look at them. Well, we've got letters, so literally there's 26 right there. We've got numbers, so there's 10 right there. And I've seen dashes at least. Let's say there's 10 special characters. All right. So then let's assume that, so that's 26 and 10 and 15, let's say, like about 50 characters. So let's say that each one of these things in here, let's say is 15 long. All right. That would be 50 or 15 to the 50th power or 50 or vice versa. It's a pretty honking big number, right? But think about the number of videos that are out there. If you told me right now that YouTube has 1 billion videos out there, I'd believe that. All right. The next thing that this discusses here is iterators. You know how to use a for loop, and you know how to use a for loop, for an example, to go through an array. But objects are more complex than arrays. You could have an object that totally described a person. All right, and it would be a combination. They wouldn't all be strings, they wouldn't all be ints, etc. They'd be all sorts of stuff. All right, and it says, for example, when you want to iterate through an array, you can use a for loop or a for of or whatever. All right, it says when you use a custom object that contains a collection of items, you'll often want a way to work your way through it. In other words, you want to make your object iterable. You want to be able to step through it. Now, with the examples that we're working on, it's not a big thing. We've got 3, 4, 5, 6 properties. In real life, it's totally possible an object could have thousands of properties, all right, and thousands of methods. All right. So they show you a way that this can be done. Now, the main reason I wanted to show you this and spend a second talking about this is this will be introduced, the word next, like pretty much like this, when we get into Node.js. When you work with Node.js, quite often what you're going to see, and again, I'm just going to show you this quickly, it's not a big thing. So let's just say that I have some function or something that I call. It doesn't matter what it is. But you're going to see put in here REQ and RES. And that's the request that you make to the server, and that's the response the server returns. All right? And you see that in virtually every node function. All right? But sometimes you see this. And you put that in, the word next, if it's your function, not one that's from, you know, the package manager thing I showed you before, your own. Because what happens is if you write your own function and it does everything, it doesn't know that it's done, so it should go on. So what next does is it says just that, I'm finished, go on to the next thing. All right. Going on with that, it says iterators are useful, but they require quite a bit of work. Fortunately, JavaScript provides generator functions that automate a lot of work for you. So believe it or not, every time somebody thinks of a cool way to do something, there's somebody behind them to try to think of a cooler way to do it. And cooler typically implies more work done under the hood, less work that the developer has to do. All right? So it says you can use the asterisk operator, star, whatever you want to call it, to define a generator function. When a generator is called, as it says, the code in the body doesn't execute. Instead, it returns an iterator object. This is pretty heavy stuff. All right? And it says what? When the code in the body of the generator function executes, it runs until you literally have to code in a yield statement. You know what yield is from driving. I kind of stop and look both ways. Sort of the same kind of thing. To tell it to get going again, you put that next call in there. Like I said, this stuff is getting pretty heavy. You know, I went and looked for some good resources for you. Most of the ones that I found were, some of them were 50, 60 pages long. And I thought, you know, even if I just give them electronic copies, probably people aren't going to read it anyway. Because you're going to read a few pages and you're going to think, this is really boring. All right? So again, take a look on the bottom here, because they explain a little bit on the bottom of page 541. So the generator was basically created to try to make it easier than using the iterator. I think I mentioned this to you. You're going to hear about it starting Friday already. But we had callbacks. They were too hard. So they put syntactic sugar on top of callbacks, and they called them promises. They were too hard. So they put syntactic sugar on top of promises, and they refer to it as async await. Callbacks are basically still what's happening under the hood, whether you're using async, callback, or promises. All right. Next, as it says, they're cascading methods. Notice there, a cascading method is a method of an object that can be chained to another method. This is one of the reasons that jQuery got so powerful, because jQuery offered you the ability to do a lot of work with animation and a lot of work with color, etc., where you could chain all sorts of things together. And the way it works is pretty much the way you think it would work. It does this, and as soon as that's done, it does this. And when you chain, I mean, sometimes, especially in like jQuery, you'd see chains that would be, there'd be a couple dozen of them together, all right? And if you're going to do that, then typically it's fairly important that a lot of times you'll see this inside of try-catch blocks, because as you're going through this, somewhere along the line, the thing may fail. And it's kind of like a database, depending on what you're working with. If I put this, dot this, dot this, dot this, if I've got 20 of these that I'm doing, and let's say I get through 15 and it fails, do I want to roll back? Or do I want those 15 that work to take effect? Type of an idea. And that's what they're talking about in here. All right. I'd say if you're going to read any part of this chapter, I would read this little subsection that starts on page 544, when they talk about destructuring an object. All right, as it says here, the figure on the next page shows how to destructure the syntax to assign values to individual constants. So when you destructure something, you saw a little bit of this the other day. All right, we're creating a new object here. This is basically a variable that has two parts. Does that make sense? But it's one variable. It's not an array. It's an object. It's got a key of first name and a value of Grace. It's got a key of last name and a value of Hopper. It's got a key of DOB for date of birth and a value of none. But if you want to be able to pluck out and work with the individual components, that's the destructuring, like they start to show here. Here we only care about the first name and the last name. We don't care about the date of birth in this example. That's why as they show there, it will display null. So as they mention here, the destructuring syntax provides a way to assign the values of object properties to multiple constants, or if you're using const, or multiple variables if you're using let in one statement. All right, static, we're going to see an example of this in just a couple minutes. But if something is static, it belongs to the class. It doesn't belong to the objects of the class. So there's one copy of it and everybody shares it. I think I've given you this example before. I'm going to say it quick because I want to finish this chapter. All right, and that is that imagine that let's just say that we were making houses. All right, so I create a class called house, and then I make a bunch of house objects. If every time I make a new house object, I want to add one to my counter of house objects, then that variable, that counter for my house object, must be static. Because if each one of them had their own value, they would all equal 1. So if I made 10 houses, I'd have 10 variables, each with a value of 1. If I made it static, there'd be one of them with a value of 10. If you get that, there's not much more to it than that. They give an example in here as well. And that's just about it. So they've got this task list. So they go back and do this to-do list. All right. And again, the JavaScript, it's an interesting enough one that's in here. They break it up into multiple files. All right. So that was a little longer than I'd hoped it was going to be, but I believe we're finished. So what we are going to do right now, it's 106. Let's come back at 120. All right. Now we're going to start looking at these examples that are in here. Now, what might make it just as easy for you as anything else, I'm just going to recommend that when we're working on this, because it seemed to work well this morning, is just go in and, for example, just go out, take your favorite website. Like I'll just go out to cnn.com, all right, then right mouse click and choose inspect, okay? And that'll keep, basically, as you start working on it, I don't want, let's see, where do I got? All right, and over here is where we're going to be working. Okay? All right, so like I said, 120, please.
I think I'm having a problem